Hey, good. Have anyone done the lab of the BGP that I gave you that yesterday, right? The commands and everything. Anyone? No?
Yeah.
You really haven't. Okay, not not a big deal. So let me open my paint file. Now let's start the lab with this guy. Okay, not this one that I'm looking for right now. BGP, BGP versus IBGP. Let's get the labs for this guy. Come on. So the first we need to understand the neighborship between the direct neighborship, and then we'll go with the indirect as well. So let's understand. Let me change this icon of this router first of all, right? As the change symbol, and I have a ring, and here we go with the red color. That's main. That's the router. And okay, so we have router number one, and we have router two as well. And then we go with the router three and router four, right? So what I'm gonna do that, so between the router one and router two, we have a link between this guy.
Parce que si ça monte, rarement maintenant les bras tout quoi. Tu vois que
Right? And then we have a link between router three to router four, right? So same behavior. What I can do that first we'll do the direct neighborship, and then we'll go with the indirect neighborship as well. So what I can do that, let me do the link between this guy to this guy, and I have a link between the 12.1 between this guy, and then we have a 10.1 to 12.0/24. And there's a link to LR2, right? So router one and router two we have, and same thing, we have a loop back as well. So later we'll do the indirect neighborship between this guy to this guy. And same thing, we'll do the loop back over there, loop back number one over there, 2.2.2. Same thing, we have router three and router four. So the link between router three and router four will be 34.3. This guy go with the 10.1 or 34.0/24. This guy go with the 34.4, right? I have a one loop back behind the R3. It's a 3.3.3.3.3.3, and I have a loop back behind the R4. That's a 4.4.4.4.4, right? So I have a loop backs over there, right? And that's fine. What I can do that, let's do the configuration, right? So if you guys remember that we did the configuration of yesterday as well, right? So let's do the direct neighborship configuration first of all. So how you can do that as the direct BGP direct neighborship, right? So on the router number one, I just say the interface 0/0 first of all, right? And IP address will be 10.1.12.1/24. No shut interface, no back number one. Guys, if you have any question during the command line, you can ask me. Anyways, we have seen this thing yesterday, right? So if you have gone through the video, then you must not have issues, right? But if you haven't, then definitely you must have issues, right? Config terminal, and same thing over this guy, interface 0/0 IP address 10.1.12.2/24. No shut interface, loop back number one IP address will be 2.2.2.2.2.2. And here we same thing on the router 3 now we have as well. Router 3, I'll just copy and paste it, right? So router 3, I can see that this guy, so we'll go with the 34.3. And this guy go with the 34.4. Right? So this is the loop back on the R3 is the 3.3.3.3.3. No? No? Call करते हैं आपको right. This is the 4.4.4. Right? So all done, right? So router 3, router 4, router 1, and router 2. So let me do this configuration. I'll take a, let me check what is my port size right now. And looks like it's 9. I'll change this guy into the 16 right now. Okay, session default setting and save it. That's done. Right. So first, let's do the copy IP configuration, then we'll start the BGP one. So let me do one thing. Let's start with the X. Right. And come on. All done, right? So let's go back to this guy out of one. Config him. I'll say this guy. Let's configure this guy now. And do the save this configuration. And same way we'll do this guy as well. Config to R2. And then we have a R3 as well. Copy. Right. And done. And now R4 we have. All done. So now we need to do the route that BGP neighborship. So between the router 1 and router 2, what we can do the router BGP number 1. So of course, this guy is gonna use the ACE number 1. And this guy is, let me change the color of this guy. Next, edit, select font. I see the footing and change the color. I'll go with the red. So this is the ACE number 1. This is the ACE number 2. Of course, between this guy to this guy, we are gonna have a eBGP relationship. And same thing, if you go over there, it's gonna use the same ACE number. So between the R3 and R4, we are gonna use the ACE 34 over there. So ACE is a 16-bit and 32-bit as well. So it's up to you which one you're gonna use. So right now the reason to introduce the 4-byte of ACE number, or we can say the 32-bit, because we are exhausted with the 16-bit of number. That's why in the market nowadays we have a 32-bit, but 32-bit only comes in the picture when you have a higher version. In the older version, you don't see the 32-bit. You only see the 16-bit over there. So let's do the configuration, the router 1. I'll say the router 1, router BGP router ID. That's like to configure the manual router ID over there. Neighborship, I'm gonna say that, hey, let's form the neighborship, the two remote AS will be 2 over there. On R2 router BGP number 1, I said the BGP router ID will be 2.2.2.2. 12.1 and remote AS will be 1. That's all. So I also told you that if you remember, so BGP always looks the reachability, right? The neighbor reachability. If you don't have reachability, then it won't form the neighborship. Because BGP works on the TCP protocol, right? So this should be changed over there. And all good. So now wait for some time. BGP is a slow protocol, so you need to wait for some time. So by default, the keep alive packet you can call as a hello packet is a 60 second. So if there is a no reply is coming till 180 second, that's called as a hold on time. So the neighbor will decide, okay, then my neighbor is down, so I need to drop. So for example, so each router is going to exchange the keep alive packet every 60 second over there. Right? It's a periodic packet, like a hello packet of the HRP NOSPA packet. So somehow if the router, take example, router 1 is sending the keep alive packet to the router 2 at every 60 seconds, but router 2 is not sending the any keep alive packet to the router number 1. It will wait for the 180 seconds. After that, what happened, router 1 is considered my neighbor is dead. So compared to the any other routing protocol right now in the market, like EIGRP, BGP is a little slow protocol. See, there's a reason behind it to make us slow, because BGP is designed for the handle millions of the route, right? So that's why it's make this guy as a better, because if it is gonna faster protocol, then what happen? Keep the millions of the route will be changed in my routing table, right? So all done. So you can see that my neighbor is up with the 12 or 2 right now. Router 1 is saying that. And if you see the command show IP BGP neighbor, I can see that on the router number 1, you can see that my neighbor is 12 or 2 right now, and remote is 2. This is the external link, means eBGP. By default, BGP version 4 is there. We also have not also have right now. Initially, it was a BGP version 1, BGP version 2, and BGP version 3. The reason we are not using this three guys, because it's a class routing protocol. So it cannot handle the classless route, right? So subnetted route, it cannot handle whether version 1, version 2, and version 3, right? So that's why in the market, we are using the version 4. And router 1 is saying that, hey, my router ID, neighbor router ID is what? It's 2.2.2.2. So BGP state is established. We'll discuss this state, don't worry about that. It's up 40 seconds ago. So keep alive time is a 60 second by default, and hold on time is a 180 second. So this will give you the huge information, right? Many information you will understand when you go in the CCI level and the CCI service provider level, because it's a huge things, right? But I don't want to see all this information right now. I just want to confirm that, okay, my neighbor is up or not. So what verification command you can use it? Instead of putting the show IP BGP neighbor, you can just put the command over there, show IP BGP summary. I need a summary information, not the detailed information. So summary information will say, hey, my router ID is a 1.1.1, my local host number is 1.1.1, neighbor is 12.2 right now. They are using the BGP version 4, and they are using the neighbor AS number is 2 over there. How many messages I have sent and received is a 4. Table version is just gonna tell you how many times your BGP table, right? This is the BGP table you have. So BGP, if you see, this is the BGP table. Right now it's not there because we haven't advertised the init out. So how many times this BGP table has been reset? That's the meaning of table version over there. So whenever you will receive the update packet, this table version will be keep increasing. This table version and BGP version, it's totally different. So this table version will be keep incrementing by 1 whenever they will update the BGP table. But BGP version will be fixed over there, which is by default 4 over there. How many packets are present in the input and output queue, and how many packets I have received from the neighbor? Sorry, how many prefix I received from the neighbor? So nothing I have received from my neighbor right now. That's why saying a 0 over there, right? Same thing, we can do the iBGP configuration. You can see the R3 and R4. It's the same AS number. So you can do the same configure out of BGP number 1. And so BGP router ID will be 3.3.3.3.3. Neighborship will be 10.1.34.4. Remote AS will be same AS number. Okay, my bad. Right? On R4 as well, router BGP number 34 over there, right? And BGP router ID will be 4.4. Even if you don't define the BGP router ID, that's fine. Let's define the neighbor 10.1.34.3. Right? That's it. So on R3, I can put this configuration. And on R4, I'll put this guy. So always remember, first it will do the three-way handshake process, sync plus acknowledgement, right? And then acknowledgement. So once the three-way handshake process will be done, right? Then the BGP neighbors comes in the picture. Right? So we have a neighborship is up. So if you see on the router 3 right now, so IP BGP neighbor, right? So it will give you the detailed information. On a router 4 I'm present right now. So you can see that my neighbor is 34.3, which is gonna use the internal link. So if you see over here, it's showing the external link, means eBGP, right? And over here, it's showing the internal link, that's the meaning of iBGP over there. So that's how you can form the direct neighborship. Same how, like you can also do the indirect neighborship as well. Let me do this lab. All done. iBGP direct neighborship now. Same thing, let's do the eBGP indirect neighborship. Right? So on the router number 1, what we have to do that first of all, guys, we need to provide the routing, because if the reachability is not there between the loopback to loopback, you cannot form the neighborship. So I said the IP root 2.0.0.0.0 and 10.1.12. Then I said the router BGP number 1. BGP router ID will be 101.1. So the neighbor will be 2.2.2.2. Neighbor will be 2.2.2.2. Update source loop back, right? Because I need to change the source over there. But because by default the source will be the exit interface, right? So we need to change the source. And this is a neighbor 2.2.2.2 eBGP multi-hop, right? That's that's done. On router number 2 as well, right? I said the IP root 1.0.0.0 because always we need a rich utility in the BGP protocol. So to make a rich utility, you can use the anything, right? So either you can use the EIGRP or static route, anything is fine, except the default route. The reason not to use the default route because default route is not a reliable route. BGP is saying that, hey, TCP protocol is a reliable protocol. I need to have a same person in my routing table. I need to have a same person in my routing table, then I'm going to form the neighborship. So don't use the default route. So this is a very important question in the interview as well. So they will give you the scenario and say that, hey, you know one thing, I just give the default route from here to here. I just give the default route from here to here. I have a rich utility, but I still not from the neighborship because default route is not reliable. Because BGP is saying that, hey, I need to have a same person in my routing table. So if I have a 2.0.0 in my routing table, then I can form the neighborship with the 2.0.0. If I have a 0.0.0, I will not allow to form the neighborship. All done. Update source, you can use the source shortcut keyword as well. Update source to back number 1, neighbor 10.1.12.1. And here what I can do that, if you remember yesterday I told you, I'm not going to define the any TTL value. I'll just going to put the enter. So by default, it will take the 255. I'm sorry. Okay. Where's the mistake? Routing. Now wait for some time. It will give you the eBGP message. Still not. What's the reason? Okay, man. My bad. No one has noticed that. All done. And hit it. So now you can see that router 2 has a two neighborship. One is called the direct neighborship and one is called the indirect neighborship. So if a BGP summary, you can see that I have one neighborship with the 101.1. I'm on the router number 2 right now. I have a one neighborship with the 101 and I have another neighborship with the 10.1 or 12.1. So both are saying that I haven't received any prefix because I haven't advertised it yet, right? Next thing I can do the indirect neighborship, indirect IBGP neighborship, right? One thing that I want to show you, I haven't put the TTL value over there. So if you see the show run section BGP, you will see that the TTL is by default 255 it will take if you don't define the TTL value. So that's not a good practice. Always define the use case TTL, whatever the requirement you have over there. So the reason I'm saying that why, because you know, in future when you go the advanced level, this will be click in your mind. Right? So on R3 as well now. So on R3, what I can do that instead of the static route, right, I can use the EIGRP just to show you that. So router EIGRP 3.0.0.0, right? On the router 3 now, I need a reachability, man. I can do anything with the reachability. So I can go with the static route. I can go with the EIGRP host as well. And now on the router 3, now what I can do that? Let's say router BGP number 1. BGP router ID will be 3.3.3.3.3, 4.4.4.4. Yes, can anyone tell me what is the default TTL value for the IBGP? What is the default TTL value for the IBGP? Anyone?
1, sir.
Great, good answer. It's a very bad answer. By default, it's 255.
Okay, sir.
Right, update source loop back number 1, that's done. So by default, the TTL for the IBGP is 255. That's why we don't need to define the eBGP multi-hop command, right? So now R3, I just need to put this command first of all, right? Because we need a reachability as well. So if you name first, you need to form the neighborship in the BGP protocol. That's the steps. And then you are going to advertise the route. So now you can see that. So IPBGP summary. Wait for some time. Yeah, it's up now. So I'm present on the router 4 right now. You can see on the router 4, I have a one neighborship with the direct neighborship, right? I have another neighborship with the indirect neighborship. Right? So this is the how you can form the direct neighborship or indirect neighborship, right? Now what I can do that, I'll add the few loopbacks more over there, and I'll consider this loopbacks are my LAN network. VLAN number 10, loopback number 2, VLAN number 20. Same thing, I'm gonna assume that these are my customer route. Okay, so I'll consider this guy as a 20. That's for the VLAN number 10. And this guy I'm going to say the 40. That's for the VLAN number 20 over there. So these are the loopbacks that I'm going to create on the router number 1 now, so that I can show you the network statement. And router 1, I'll say the interface loopback number 1, not loopback number 1, interface loopback number 2. IP address, let me do this lab in Notepad. Network statement on router 1, interface loopback number 2, IP address will be 10.10.10.10.10. Interface loopback number 3 will be, it's 100.100.100.100. All good. On router 2 as well, right? Router BGP or not router BGP, of course. Interface loopback number 2. IP address will be 20.20.20.20.20. And interface loopback number 3, 40.40.40.40.40. Right? So let's do this loopback on router 1 as well and 2. Okay, man. My subnet is same right now, so what I can do that. Fine, right? Not a big deal. So one thing that you need to notice over there, these are my classless and class pulled out over there, right? And router 2 as well. Now, how I'm going to advertise the route? To advertise the route, we need to use the network statement. Now, if I talk about the BGP network statement that I already told you yesterday, if you remember that. Okay, I can't do that now. I need to use a different one. So in normally, if you remember that in what we call in a AHRP routing protocol, this is called as what? This is called as a prefix. In the static route, normally this is called as what? We call as a route. Sometimes in a AHRP also we call as a route as well, right? Sometimes people call as a successor as well, successor path. In a OSPF protocol, we call this guy as a what? This call as a LSAs over there, right? Then if I talk about the ISS protocol, if I talk about, right, in ISS protocol, this is same thing, right? We have a multiple names over there. We call as LSPs over there, right? But if I talk about the BGP now, in BGP, we call this guy as a NLRI. NLRI stands for Network Layer Reachability Information. So basically just a name, don't confuse with this thing. It is a combination of the two things. The first is a prefix, right? And the prefix length over there. So analyze nothing but just a combination of two things. So one is called a prefix and prefix length. So prefix is gonna say the 1 or 0 or 0 or 0 or 0. Prefix length is basically your subnet mask information. That's a 255.0.0.0. That's all. So in a BGP protocol, what happened, right? We are basically extending the NLRI information, not the route information. So like in OSPF, we are extending the LSA's information. Same like in the BGP protocol, we are extending the NLRI information. In NLRI is nothing but it's just a combination of the two things, prefix and prefix length over there. Now, if you see one thing on the router 1, how you can advertise the route. So the network extension of BGP is the router 1. I said the router BGP number 1, right? BGP is the network. Now network is what? One thing you have to understand. Let me write on this thing. So the syntax of the network extender, if I talk about in the iOS router, it's differ on a different iOS as well. So on a XR, it's different. On a Nexus, it's different. I'm talking about the iOS perspective. Right? On the iOS, what happened? You used to give the command like network, right? And what? I just put the 1 or 0 or 0 or 0. That's all. Make sure that your same subnet, exact same, you need to perform the exact match. Exact same should be present in your routing table. So have a look. I don't have 1 or 0, I have a 100 or 0. So have a look in the routing table. Do I have a same information 100 or 0 or 0 or 0 in my routing table? Yep. I have. So if you have, then it's fine. You can advertise this guy. So the router will advertise it. So if I'm going to put the router BGP right now, have a look. Right? If I'm going to put this command, router 1 is going to advertise this route to the router number 2. It will send the update packet. So if you're going to enable the update over there, debug IP BGP update, right? And on the router 1, if I'm going to put this command, what happened? Router 1 is going to advertise this route to the router number 2. Can you see that I received the update from the 12.1? So router 1 is sending the update packet to the router number 2. In this update packet, they put the information about the 100.0.0/8. So it will perform the exact match. But if I'm going to put the command, understand this guy, if I'm going to put the command network, 1 minute, I haven't configured the 170. No. But if you see, if I'm going to say that do show IP root connected, have a look over there, right? If I'm going to say that network, right, router BGP number 1, if I say the network 172.16 or right, have a look over there. If I'm going to say the 0 or 0 or 0, have a look. Will I advertise the route? No, I won't. Do you see any update packet that I've received from the router 1? No. So in a BGP protocol, what happened? In a BGP protocol, what happened? You need to perform the exact match. So have a look in your routing table. What is the exact match we have over there? So if I'm going to put the command network 170.16 or 100, will it work? Of course not. The reason is that, right, if you have a classful network, for the classful network, this command is fine. For the classful network, this command is fine because by default, what classful network understand? Because we have a default submit masking information. But if you have a classless network, then you need to use the network 170.16 or 100, that's a network portion. And then you need to specify, hey, the mask is not a default, which is 16, it is now a 24 over there. So when you have a classless network, better to use the mask keyword to define the exact mask information. So if you see, this is the exact match we have, right? /24. And now router 1 can send the update packet to the router 2. Do you see that? So now which one is the recommendation one? This one and this one. So always if I talk about the recommendation is what? Recommendation is network. This is the syntax we have. The prefix, right? And then mask, and then you need to put the submit mask information. This is the good way to advertise the route. See, if you have a class pool, you can go with this way. That's fine. If you have a classless, then you have to go with this way. But don't confuse with the both the things. Go with the this way, because in future, if you're gonna do it with the advanced lab, for example, when you're gonna do the lab on the XR router, service provider routers, right? When you're gonna do the lab on the Nexus routers, sorry, Nexus switches, right? Over there, you have to do this kind of configuration over there. And in a protection network, right, it is always to do this kind of configuration, not this kind of configuration. Okay, so that's a good way to do that. Okay, apart from this thing, you can do this way as well in your practice, but this is the better way to do advertise the network. You need to put the complete command line. So same thing, if you see right now on the router number 2 as well. On a router number 2 as well, if you see the router BGP right now 2, and if you see over there, both are my classful network. So do I need to add the mask keyword? No, not a mandatory, but it's a recommendation to add it. It's a recommendation. It's not a mandatory. It's a recommendation to add it. Same thing. That's all. All done. Right? So now you can see that this is the eBGP route. So on a router 2, if you see, so IP route BGP protocol. So you can see that I received the route 100.0.0.0 from the 2080 because it's an eBGP one, and this as well. Right? Same thing, same behavior will be on a router 3 and router 4. That's iBGP. So let's make a loop back over there. I'll say the loop back number. Okay, let's make a 30.30.30.30. That's a classless route. Okay. And on this guy, I'll make this guy as a, this would be loop back number 2. Okay. And this guy, I'm going to say that, hey, loop back number 2. OD dot /24. Right? So now let's go on R3 interface loop back number 2. IP address will be 30.30.30.30. Right? So in this case, I'm using the both are my classless route. Right? So what command I need to use? Again, mask mode. I need to define the mask exact match 30.0. Then this guy. Same thing on the router 4 right now, right? Because we need to perform the exact match. So 24 bit, you can see that. In your routing table, if you see, do show IP route connected. It's the exact match we have, right? All good. And then submit mask information. Same thing on the router 4 as well. Let me do this configuration router 3 as well. R3 34.4. All good. R4. Looks like why I'll come to me, man. 40.40.40 0. And here we go. Right. So I'll just copy and paste this configuration R4 as well. I haven't have a loop back, so let me add this loop back. First of all, interface loop back number 2. 40.40.40.40. If you wanna add the description, loop back. Right. Okay, not this way. So this way. So that's how you can advertise the route. So even if you see on the route 3 right now, show IP route BGP, you can see that the AD is a 200. So that's a major difference. So here you will see the AD is a 20 and here you will see the AD is a 200 over there. So this is the part that we have done yesterday, guys, in the paint file. Okay. So the network statement is just going to advertise the network. Neighbor statement. Neighbor statement is just going to enable the interface. So that's a major difference that. So in IGP protocol, the network statement is enabling the interface, but in the BGP network statement is not enabling the interface. To enable the interface, we need to use the neighbor statement. Now the next thing is what? So this is the basic lab that we did. Now let's go with the, let me pause this guy and I have another lab. Okay. So before I'm going to show you this lab, I want to show you that I have a lab, so it will not take so much time. Loop prevention mechanism, that will go with the advanced level. Yes, just give me 1 minute. Let me get some tissues. All good. So now we have to go eBGP loop prevention. Right? How we can prevent the loop in the eBGP protocol? If you remember that, I told you that in a eBGP, if you want to prevent the loop, AS path, right? How? Before I'm going to explain you how, first, let's configure the lab. So let me explain you what is the lab over there right now. So we have a router 1. You can see the AS number 1. This is the Cisco company that's router 1 is going to use. So Nokia, router 2 is going to use the Nokia company. That's ace number 2. Router 3 is going to use the Juniper right now. Ace number 3. And router 4 is going to use the Arista network. All they have a network between this guy to this guy, right? It's 12.078 and 23.078 and 34.078 and 14.078 right now, right? And what I can do that, I'm gonna make the eBGP neighborship. Of course, between the different ace number, I'm gonna use the eBGP neighborship. And then we'll see how does the eBGP prevent the loop. I could explain you in the theory as well, but better to go with the practical, then you will see, understand the lab. So the first thing is what you can do that on router 1. So already you can see the IP addresses configured in the diagram. So I think so, as I'm remembering right now, IP is pre-configured. Let me check. All done. And let's have a look. Show IP interface brief. Perfect. I do have. Let me check on the router 2 right now. Perfect. Router 3. All good. Router 4. All good. So on the router number 1, I can do that router BGP number 1 as the BGP router ID will be neighbor. So 2 neighbor I have 2 which is gonna use the AS number 2, the Nokia company, and another neighbor I have Arista on router number 1. Okay, perfect. I'm not gonna advertise the route right now. Let's do the neighborship first of all. What? Okay. And here you go. R3. R3 will be 34.4. R4 now. Right, R4 will be have a R3. And 14.1. Done, right? R1. R2. R3. R4. Right, so of course router 1 is going to form the neighborship with the 2 routers. So router 1 is going to make the neighborship with the Nokia and Arista. Router 2 is going to form the neighborship with the Cisco and Juniper. Router 3 is going to form the neighborship with the Nokia and Arista again, right? So you can see that router 1 has a 2 neighborship right now. The command is do show IP BGP summary. That will show you the neighborship right now is up. Right? Even if you check in the router 2 right now. So IP BGP summary, I have a neighborship with the 12.1 and 23.3 as well. Same command on the router 3 now. All done. And router 4. All good. Now what I can do that, understand the concept right now. So I'm going to advertise the router from the router number 1. Router 1 is going to share this information to the router 2 right now. And when he's going to send the update packet, in this update packet, what happened? He will prepend the own AS number, right? He will prepend the own AS number. So he will put the AS number 1. When router 2 will receive this router, he will say that, hey, 1 or 0 or 0 or 0 or 0 or 0. AS number will be 1, right? When router 2 is going to send the update packet to the router 3 right now, router 2 is going to prepend the own AS number. Prepend means what? He will put the AS number in the first right now. So router 3, he will send the update like this way, 1 or 0 or 0 or 0. Now 2 and 1. So R3 will have a BGP table like this way. When R3 is going to send this update to this guy, right? He will prepend the own AS number. Prepending means what? He will put the own AS number first right now. R4 will have this information, 3, 2, 1. And then R4, understand the concept. When R4 is going to send the update packet to the router number 1, in this update packet, what information they will put? 1 or 0 or 0 or 0. I'll put the AS number prepend 4, 3, 2, 1. So when the router 1 will receive this AS number, I say the Cisco will receive this AS update packet. What Cisco will tell that? Okay, this is the 1 or 0 or 0 route. Perfect. I don't have any issue. This route is coming from the AS number 4, which is the Arista network. Okay. This route is coming from the AS number 3, which is the Juniper network. This is Cisco is saying that. Understand this concept because I'm receiving the update packet on this particular interface. Then Cisco is saying that, okay, I'm receiving the update from the AS number 2, which is the Nokia router. But what I see over there, AS number 1, this is the my update packet and it's come back to me, right? Because my AS number is also 1 over there and this update packet also contain the AS number 1. So immediately what happened, router 1 will discard this update packet saying that, hey, there is a loop in between network. So AS path information is used to prevent the loop. So if you have a loop right now on the router number 1, debug IP BGP update packet. And router 1, if I'm going to advertise the route, right? I already have a loop back. Can you see one thing? I received the update from the 14.4, right? And what I'm doing that, due to the AS part contains CO and TANS, our own AS number. So R1 is never going to accept the update packet from the R4 because it's have a same AS number 1. All good? So this is how you are preventing the loop in the ABGP protocol, guys. Don't worry about this thing star and the greater than sign. We'll discuss this thing later. Don't worry about that. Okay, so let's do the loop prevention mechanism for the IBGP as well. So AS path is used to prevent the loop. IBGP loop prevention, IBGP formation, not formation. Yeah. Okay, so of course, this is the same company, AS number 1. I can make AS number 1 to 3. I can so far. Cisco. Right? So let me write on IBGP split IBGP loop prevention mechanism. So how we can prevent the loop prevention in the IBGP? The first thing, I'll tell you one thing. In IBGP update packet, right? In IBGP update packet, you don't see, or we can see that in IBGP update packet, ACE path information is not present. So IBGP never exchange the ACE path information. So normally when the router 1 is going to share this information to the router number 2, the update packet, it will just say the 1.0.0.0/8 information. That's all. There will be no ACE path. So if the ACE path will be not there, how we can prevent the loop? So that's why the IBGP split horizon rule comes in the picture. How it's gonna work? So IBGP split horizon rule say that whenever IBGP router receive the update from IBGP neighbor, whenever IBGP router receive the update from IBGP neighbor, it will install the route, but it won't share the same information to another IBGP neighbor. I'll explain you what is the meaning of that. First, I'll show you this part that IBGP does not contain the ACE path information. Okay. Let me check what the IP addresses they are not, first of all. All I have 12.1 and 1.1 as a loopback. So IP interface brief. I have a 12.2 and 23.2 on this particular interface, router 2. Router 3 I have, so IP interface brief. I have a 23.3 and the 3.3 as a loopback. Perfect. So I'll just go on router number 1 and first start the configuration. 1, 2, 3. Neighborship. All good. I'm not going to advertise the route right now. I'll just make the neighborship right now. That's all. V3 and I have a remote ASL 1 to 3 now. R3 router BGP 1 to 3, BGP router ID will be, come on, 3.3.3.3.3 and 23.2 and here we go. 1 to 3. R1. Bingo. R2. Bingo. And R3. All done. So router 2 is going to form the two neighborship, one with the router 1 and router 3. And router 1 is going to form the one neighborship. One is the router 2 only. And router 3 is going to form the one neighborship, right? Perfect. So let's capture this particular link. I'll show you the NLRI and the update packet as well. That doesn't contain the AS path. So if you see, reminder me later, and here you go. I put the network statement over there. That's a 100.0.0.0. And you don't see the AS path information in the update packet. Why it's not coming? I do have it out, right? Do so IP route connected. I have it. Wait, it will take some time. Yeah, it's coming up. No, it's a keep alive message. So the keep alive message is the normal packet. It doesn't have any information over there. So BGP is a totally unicast. There is no multicast packet over there. Can you see that? It's a totally unicast packet. And BGP works on the TCP protocol, the port number 179. So waiting for the update packet. So now you can see the update, Control M. I can mark this packet. You can see that Rado 1, that's a 12.1 is sending the packet to the 12.2 right now. Open this packet. Source IP is the 12.1, destination IP 12.2. If you're going to open the IP TTL field over there, this is the TTL for the IBGP is by default 255, right? That I told you that. And if you go to the BGP update message, right, you can see the network layer reachability information NLRI. So we have a 100.0.0.0. So NLRI is the combination of two things: prefix length, that's a subnet mask information, and prefix we have 100.0.0.0. If you go to the path attributes right now, this is the update message. If you go to the path attributes right now, you will see the AS path is empty, right? I'll explain you what is path attributes. Don't worry about that. But they see AS path is empty. So IBGP does not contain the AS path information. Now what happened over there? If you see, so if I'm not going to put the AS path information, how we can prevent the loop based on the IBGP split Trojan rule? And what IBGP say that? Understand you are sitting on the router number 2, right? And what is, whenever IBGP router receive the update from the IBGP neighbor. So this is the IBGP router. I received the update from the IBGP neighbor. What I will do now? It will install the route in the routing table, or we can say the BGP table, but it won't share the information to the another IBGP neighbor. So it will never share the information to this guy. Same thing will be opposite. When R3 is going to advertise the route 3.0.0.0. When R3 is going to advertise the route, same rule will be applied to the R3 as well. So R3 will share the information to the router 2, right? R3 will share the information to the router 2. But router 2 will receive this information, but router 2 will never share the information to the another IBGP neighbor. It means that router 2 have both information. Router 2 have both information. So this I is gonna represent that it's a IBGP route. So normally in the eBGP, you will not see this I over there. This star sign is gonna represent it's a valid route. Okay. And this greater than sign is gonna tell you it's a best route. So if the route is best, then it will install in the routing table as well. If the route is best, right? As well. So if you see right now, my route is best. That's why I can see this information, and it will also there in the routing table as well. But the problem is what? On R3, if you have a look over there, you don't see the route from the R1 because of IBGP split Trojan rule. Same thing, if you check on the router number 1, Do I see the route from the R3? No. So R1 will share this information to the IBGP router, but IBGP router will never share the same information to the another IBGP router. Same thing, R3 will share this information to the IBGP router, but IBGP router will never share the same information to the another IBGP router. That's a problem. Not a problem. It's a like loop prevention mechanism of the IBGP protocol. This is happening because of the IBGP split horizon rule is by default enabled. This is by default enabled, and this is happening because of this guy. So that's how we are preventing the loop in the IBGP. But see, try to understand, but this is not a good thing, right? Okay, you are preventing the loop, that's fine. But the problem is what? We don't see the end-to-end communication. Because R3 doesn't know about the 1.0.0 and R1 doesn't know the 3.0.0.0. So to avoid this problem, right? To avoid not avoid, because to disable a split horizon rule behavior, we have three solutions. The first solution is known as a full mesh. So you can treat the topology as a full mesh. So each router is going to form the neighborship with each router. Second solution is called as a route reflector. And the third solution is known as a configuration. So the full mesh is in your syllabus as well. RR is in your syllabus as well, but not the configuration. It's normally comes in the CCI part, right? But we'll see the configuration as well. Don't worry about that. We'll do the configuration lab as well. So the full mesh is the first you need to go with the solution. The full mesh is what? Full mesh, you need to make a neighborship between this guy to this guy. So I already have a neighborship between this guy to this guy. I already have a neighborship between this guy to this guy right now. I'm going to make the neighborship between this guy to this guy as well. That's called as a full mesh. Every router has a neighborship with every router. Right? That's why we can disable the split horizon rule. And that's how the indirect neighbors comes in the picture. Router 1 is going to form the neighborship with the 23.3, right? From one broadcast domain to the another broadcast domain. And router 3 is going to form the neighborship with the R1, 12.1 from one broadcast domain to the another broadcast domain. And if you're going to form the neighborship between the two different broadcast domain, what we need over there? Routing. So to achieve the full mesh, right, what we can do that? So achieve the full mesh, what we can do that? I already have a neighborship right now. Let me write on this command. Right? I already have a neighborship with this guy. I just need to make the neighborship with the 23.3 and router number 1. And remote AS will be same. On router 3 as well, I'm going to make the neighborship with the 12.1. Do I need to use the source keyword? Of course not, because I'm making the neighborship between the exit interface to the exit interface, right? So no need to change the source of there. All done, right? Next part is what? I just need to have a reachability, right? So if you don't have reachability, they will not form the neighborship. So router 1, I'll just put this command, and router 3 as well. So I'm already in the BGP mode right now. You can see that. I'll just put the configuration. So they won't form the neighborship. So what we can do that? We need to provide the routing. So on the router number 1, and 12.2. And router 3 as well. Because if you don't have a routing, the neighborship never comes in the picture. Routing must be there. BGP works on the TCP protocol and TCP needs a reachability. Always. So now you will see the pop-up message for the BGP. And now once the pop-up message will become, right, what happened now, router 1 can share this update packet to the router 3 and router 3 can share the update packet to the router 1. So we have a good to good reachability now. Okay. My bad. I missed that. So it was a wrong configuration. So now you can see that my neighbor is up. And if you see now, do previously, I don't see the any route. If you see the do show ip.bgp, I did it. I don't see the 1.0.0. Now if I'm going to put the same command, do show ip.bgp, I see the 1.0. 14 seconds ago, I learned this information. And this route is a valid and best as well. So if you say do show ip.bgp, this route is a valid and best. And this is the I is going to represent the internal route. It means the IBGP route. I learned this route from the 12.1 next hop. The meaning of 0.0 next hop is what? It's a locally originated route. Locally originated route means what? Router 3 itself has generated this route. Right? Same thing on the router 1. If you see that, do show IP BGP, or first see the route BGP now. Previously, we don't see the route. Now I can see this 3.0.0 in my routing table. That's a 200 is the 80 value. And now you can see the same thing, do show IP BGP. I can see the 3.0.0. I'm getting this route from the 23.3, right? That's my next route. And 1.0 is my locally originated route. So that's how you can do the full mesh. But the only problem with the full mesh is what? You know, the major issue with the full mesh. The full mesh will give you the lots of configuration. So right now it's just 2 routers, right? 3 routers right now. That's fine. But take example, if you have a 20 routers. If you have a 20 routers in your network, then how many configuration you're gonna put out there? So on the router number 1, you're gonna put the neighbor R2, neighbor R3, neighbor R4, neighbor R5, neighbor R6, neighbor R7, neighbor R8, neighbor R9, neighbor R10, and so on till 19. So it's equal to like the n is equal to n minus 1 divided by 2. So n is basically a router number. 20 is equal to 20 minus 1 divided by 2 is equal to 20 divided 19 divided by 2 over there. So if you're just gonna calculate, open the calculator. So 20 into 19. It's 380. If you're gonna divide this with the 2 right now, you will see that what? 190. 190 neighborship you will have in picture. 190 neighborship. The first problem, no scalability. Full mesh does not provide the scalability. Second problem, if you have 190 neighborship, then what happened? Each neighbor, right? Each neighbor will have each TCP connection. And if you have each TCP connection, then what happened? You have a memory consumption and the CPU comes in the picture. So lots of resources will be required. Wastage of bandwidth of the link. Another problem is what? Lots of configuration on each router. So there's a multiple disadvantage, man, in the full mesh configuration, right? No security because I have multiple neighborship over there right now. Each neighbor is gonna have a each TCP connection, so memory CPU comes in the picture. And for the big network, right? I just give you the 20 routers example, and 20 routers is a minimal router, I'm telling you. In a production, you will have a 50 plus routers that's running with the BGP 100 plus routers. If you see right now, router 1, in the full mesh, what happened? I just did the configuration like this way. I already have a neighborship with the 2L2. I made the new neighborship with the 23.3 as well to just exchange the route. So if you see the problem is what? I'm maintaining the 2 neighborship right now. If I'm maintaining the 2 neighborship, then what happened? I have a 2 TCP connection. It's a wastage of resources of the router. And I have extra configuration on the router. Now just for the 2 network, 3 routers right now. Take example, if you have 20 routers. So that's why we came with the solution is called as a route reflector. So another solution for this guy is what? The alternative of full mesh is what? We have a RR. So basically what RR is going to do that? It's reduce the TCP connection. The major pros, if I talk about the RR, right? Major pros of the RR is what? It reduces the TCP connection. So if the TCP connection will be reduced, of course, my neighborship will be reduced. If my neighborship will be reduced, then it means that what? I can save my memory and CPU. I can improve my router performance. I have a less number of configuration. So troubleshooting will become a very, very easy. So this is the major advantage of RR. It improves the router performance. By not using lots of CPU and memory. Then what? It's a more scalable way to do IBGP. And in the production network, I'm telling you, 90% you will see the RR, 90%. 90% you will see the RR. Remaining the 10% you will see the configuration and the full mesh. But 90% the networks are running with the RR. In the service provider side network, what happened in the major service provider, the big service provider, tier 1, tier 2, they are using the RR, they are using the configuration, and they are using the full mesh, all the 3 combination as well. But there is a reason behind it. Once you go with the that level, then you will understand these things. But yeah, it's not like that, like a full mesh has a disadvantage. So we are not going to use the full mesh. Full mesh has its own benefit as well. Right? So the reason to move the RR is what? Because the full mesh is not as scalable, right? And it requires the lots of TCP connection and the lots of memory and CPU. That's why we are going with the RR. How RR is going to work? If you see its term is saying the reflector. What do you mean by reflector? Have a look at this diagram. Let's go back in the 8th class in the school time. Light reflection. Class 10. Okay, I was thought it's in the 8th one. Can you see that? This diagram. Normally, so if you focus the any torch, right? There's a torch light was there, right? So if you're going to focus the any torch in the surface on the mirror surface, right? Then what happened? This will be reflected to the different direction. That's the meaning of reflection over there. So here the input is what? Here the input is a light over there, right? So when the light will be hit to this surface, it will reflect it to the another direction. Same thing, right? It's gonna happen with the RR as well. Instead of the light, we are gonna, the input is what? The input is my route over there. So normally what happened, router 1 we have, router 2 we have, and router 3 we have, right? So your server in the router reflector, what happened, you have a three types of component. One, we have a client, one, we have a server, and one, we have a non-client. These three components we have in the RR. So normally your server will be the always the centralized router, and all the remaining guy will be client. Okay, so now understand the concept. So when router 1 we have a 1.0.0/8 route, it will share this information to the router number 2, right? And what router 2 will do that? Router 2 is a server. So I will reflect this route to the R3, to the another client. So whenever I will receive the route from the client, I will reflect the route to the another client. So when server receive the route from client, it will reflect to another client. So in that case, what happened? Router 3 will maintain this information 1.0.0.0 without making a neighborship between this guy and this guy. Without making a neighborship between this guy and this guy, I can get that out. So I can reduce the TCP system. Previously, what happened? R1 has in a full mesh case, what happened? If you see that, R1 has a 2 TCP connection, or we can say the 2 neighborship with the 23.3 as well. But in the case of RR, you will not have a neighborship between this guy and this guy. You will only have a neighborship with the RR. So all the client, right? All the client is forming the neighborship with server only. All the client. So let's do that. So what I can do that, I'll show you the first thing, how you can make a route reflector. So simply to make a route reflector, what we can do that, I'll first remove the full mesh configuration. So what we can do that, I'll just gonna remove the 23.3 from R3 to R1 to R3 neighborship. And same thing, I'm also gonna remove my static route that I did it on R3 as well. Router BGP number 123. And also this guy as well, static route. So my name, how the configuration is my normal configuration right now, guys. My configuration is this way right now, a normal configuration. How you can do the RR now. So same will be R1 has a neighborship with the 12.2 right now, right? R2 have a neighborship with the both the router, and R3 has a neighborship with the 23.2 right now. That's a normal. How we can do that? I'm gonna make the one router as a centralized router as a server. So I'll make this guy a server. This guy's go with the client and client. So the configuration is very simple. You just need to go on the server router and see the router BGP number 123, right? I will see that, hey, listen, you are my client router. Once I put this command on the router number 2, I'm saying that, hey, you are my client and you are also my client. Automatically what happened? Router 2 will become a server. Automatically what happened when I say that, hey, you are my client and client, automatically what happened? Router 2 will become the server. And that's all, man. That's a basic configuration. That's done. So all done. So this is all about. the RR configuration. Now, if you see one thing, if you go on the router 3 right now, do show IP BGP, right? What you will see that. So when the router 1, that's a client router, is going to send the update to the router number 2, which is a server 100.0/80 information. What R2 will do that? R2 is a server, reflector we can call it. What is the behavior of the reflector? The source is what? The input is basically a route over there. So when I receive the route from the client, I have to reflect it. So now if you check on the router 3, I do have a route from the 12.1. Only the problem is what? This route is just a valid route. This route is just a valid route, not a best route. And why this route is not a best? The reason is that because on a R3, when I receive the route 1.0.0.0, the next hop of the BGP router is a 12.1. So can I reach this guy 12.1 if you see? No. Why not? Because we don't have a route to the 12.1. So there is another problem in the iBGP protocol is what? Whenever BGP router receive the update packet, it checks the next hop reachability. If the next hop is reachable, then BGP marks that route as a valid and best. If the route, guys, please pay attention, the definition is very, very important. If the route is valid and best, then it install in the routing table. And as we know that based on the routing table, router will forward the packet. Somehow, if the route is not best, right? In that case, route won't install in routing table. It's there in the BGP table, but it's not there in the routing table. And why the route is not best? Because your next hop is not reachable. So you need to provide the reachability for that one. How you can do that? Same command, IP route. Either you can do that EIGRP or anything, that's fine. Same thing if you check on the router 1 as well, do so IP BGP. I do see the 3.0.0.0 on the router number 1, but I don't see the next hop is 323.3. Remember your study lecture, what I told you that iBGP does not change the next hop. Very, very important. Never. eBGP does change the next hop. So we don't have this issue in the eBGP protocol, guys. We only have an issue in the iBGP. So if the next hop is not changing, then my reachability will be not there till the next hop. What do you mean by next hop is not changing? Understand the concept. When the router 1 is going to share this information 1.0.0.0.0.0.0, what will be the next hop? When the router 1 is going to send the update packet, it will you put the source IP will be 12.1, right? So when the router 1 or 2 will receive this information, the 1.0.0.0, 12.1 is the next hop. So router 2 can reach to the 12.1 directly, right? It's the same broadcast domain right now. But when the router 2 is going to advertise this route to the router 3, because he's a server right now, he's going to reflect the route. He will say that, okay, 1 or 0 or 0 or 0 or 0, IBGP does not change the next hop, still 12 or 1. Can I ping from the R3 to the 12 or 1? No, man. And that's why it was not reachable. So you need to provide the reachability to the 12 or 1. So if you see, I get the starting route. Now if you have a look the same command. Can you see that previously it was not reachable? That's why my next hop is not valid. Now it's reachable because I get the starting route. And now it's now it's installing the routing table as well. So if you see the do show IP root BGP now is there. Same thing on the router number 1. If you see that, I don't have my next hop is what 3.0.0, 23.3, right? Of course, because when R3 is going to send the update to the R2, 3.0.0.0, next 23.3 will be next hop. R2 can ping the 23.3, right? If you see on R2, if I can ping, it means that my route is best on R2. But how about the R1 now? Because he's a server right now, he's going to reflect the route to the router 1. Router 1 check the routing table. Hey, do I know about the 23.3 right now? Because IBGP does not change the next hop. Let's me ping this guy. No, man, I can't send the traffic. If you cannot send the traffic, then what happened? My next hop is not reachable. If my next hop is not reachable, then what happened? I cannot mark this route as a valid and best. And if the route is not a valid and best, I will never install that route in the routing table. Same process you need to do with this guy as well. And now if you see, I can ping and my route is best now. Hold on, it will take some time. Yeah. All good? So this is all about the RR and full mesh, guys. It's a very, very important topic. The next top behavior, right? The valid and best, the next route reflector, the full mesh, the eBGP loop prevention mechanism, right? These are the very, very important topics. The network statement, neighbor statement, it's like if your BGP is not good, it's a hard to crack any interview. So anybody has a question, guys, let me share this notepad. I will share with you as well. So tomorrow we'll do the configuration of the Kabul. I need to save the desktop.
Sorry, these labs are available just on the EVNG, so we don't have to configure everything. You just configure the protocol and
That's fine. Everything is so you need to draw this diagram in the evening. So I'll do one thing. Give me some time, 2 and 3 days, right? I'll do this lab, set up this lab in the EVNG for the BGP folder name. Then you can do the lab. Okay. So access this lab after maybe on Tuesday or Wednesday, you can do that lab. Okay?
yeah, I mean, if as long as the IP is done, rest. I mean,
Yeah, that's something that from the Wednesday you can access my server and do the lab. Not
okay, because it can save a lot of time, you know.
Yeah, I'll do that. I'll do that. Don't worry about that. I'll create the lab over there, and the name of the lab will be BGP folder, right?
I mean, basically you have these labs, isn't it, already, isn't it?
It's not there. The reason is that in my server, is normally the labs are the service provider and SD-WAN and data center right now.
Oh, okay.
So, and even the enterprise labs are there. So,
Mhm.
but the enterprise labs are only like a high level labs up there, like a
Sure,
CISO.
sure.
So
Yeah,
the
I mean,
yeah.
if we can do that, will be much
That's what
appreciated.
I'm saying. That just give me the 3-4 days more. Till the because I'm traveling right now on the
No, no problem.
Tuesday, right? Right,
Mhm.
Tuesday and Wednesday I'll be traveling. So what I can do that during the traveling, right? I'll set up the lab because my server is accessible, right? So I'll set up the lab in my server, so you can access the lab on the Wednesday or maybe Thursday. I'll let you
Only
know.
this lab or all the BGP
All the
labs?
BGP labs, I'll do that for you.
I mean, we just configure the protocol and just
Yeah,
do the
yeah, yeah. I'll put the
troubleshooting.
IP addressing, ACE number, everything. So I put it over there.
Okay, makes sense. Thank you so much. It can save a lot of time. Huh?
Okay, so that's great. That's I'll catch you guys. Okay, one more thing. So as I'm traveling on the Tuesday and Saturday, Tuesday and Wednesday, so of course the Puneet will take care for you the automation part and the wireless as well. And this weekend we are doing the class Saturday and Sunday.
Okay.
Timing will be 9 p.m. same time. So by the Sunday we'll done with the BGP protocol as well. So tomorrow again I have to go with doctor, right? So with my sister, right? So again I have to jump to tomorrow to the doctor hospitals again. 8 o'clock
So
is
there is no
time.
class tomorrow?
Yeah, tomorrow is no class. So 8 o'clock I have to jump and then again I have
Sure,
to
sure.
happen. So I'm not pretty sure like about the timings, like how long it will take. But yeah, looks like I have a fever right now.
Oh, okay. That's
Okay.
okay. So,
So
is a server accessible tomorrow around this time?
not tomorrow because I'm sending everything to the Delhi location right now. So it's going tomorrow morning. It will be there. So it's off. Everything is off right now.
No, no, I'm talking about tomorrow. Tomorrow,
Yeah,
not
tomorrow
today.
tomorrow also will be not there server. So that's why even the weekend batches, right? All my weekend batches, the CCI batches cancel right now due to my server relocation. So I have to also relocate my server to the Delhi right now.
Okay.
Okay, so you can access from the Wednesday. Meantime, I'll set up all the lab. If you want another server access, I can give you. I have like a few server more, which is the public IP. So the public IP will be set up. I think so. I have told to the Puneet, right? So the Airtel guy is coming tomorrow, so he will set up the new public IP to the different server. So if you
Okay.
want, then let me know. Okay.
I'll try to do this on Packet Tracer. I think this one
Yeah,
is
this lab you can do that. Basic lab, no, the how to form the BGP membership.
this one we can do on Packet Tracer, isn't it?
No, I don't think I haven't never tried the RR route reflector in the packet. You can do this lab, the full miss lab, right? The full miss lab, you can do that in the packet. But try to do
Or
this command of the route reflector as well in the packet and let me know because I never tried in the packet.
okay.
Okay, but I think so it will support because it's a basic stuff. I think so it will support. Not the high level, but the basic one will support.
Should be okay, but the server is available on the weekend. No, not really,
No,
right?
that's why I'm canceling all the batches right now.
Oh my, okay. No problem.
Yeah. Even I have to
Okay.
inform to the guys, right? Like no system with this weekend for the SD-WANs and the CCI service provider. Okay, guys,
Okay.
I'll see you on the Saturday.
I'll message you on a WhatsApp anyway if you need the details
anyways,
for
yeah,
any other server,
definitely.
right?
Yeah, definitely. No way.
Okay,
So
then. Thank you so much.
I'll see you guys on the Saturday. Saturday we'll do the stuff of the next hop cell behavior, right? And the configuration part. And then on the Sunday, we'll do the what we call the BGP path attributes. And then Monday, we'll have a class as well. Monday, we'll do the session of this thing, what we call. So we have done with the routing, then we'll jump to this things like your HSRP, VRRP, these things are there, right? And then the NAT and PAT, that NTP protocol, these are the not a big topics. It will the D topics, right? So we'll do all the topics on the end. So eventually all will be clear. So the Puneet will handle of the wireless and automation, right? For the Tuesday, Wednesday, he will cover the things, right? I have already informed the Puneet, right? So I told them just take a one lab session for the automation so that you will have a clear understanding how the lab is working for the automation. Okay, but he cannot teach you the Python, of course, right? Because normally the Python, the Python will understand the Python, it will take you 1 month, right? So he cannot teach you the Python. He will teach you how because in the NP level, it's only how the things are. Of course, the port security will also gonna do that. So don't worry about that. It's a basic topics, a small topics are there. So he will not teach you the Python. He will teach you how the automation is gonna work, how the automation is gonna is changing the current environment right now. Okay. All good. I'll see you on the Saturday, guys. Bye bye. Have a great day. Thanks, Rainy. Bye bye.
Thanks so much. Take care.
Thank you.
Bye-bye.